Assalamu alaikum.
Walaikum assalam.
Okay, we are just approaching to the end of the chapter number 2. Inshallah, we will finish today. And at the moment, we are doing the second last topic of the chapter number 2, which is iterative method convergence, order of convergence of the iterative method. And you remember that I give you the rule for that case here. Already we discussed, we did many examples also. Our method is xn plus 1 equal to something, and something is always, I told you, is what? Is a g of xn. We say this method already converges, right? Always already converges. Now we want to check slow, fast. So if we say linear, what that means? Linear mean r equal to 1. What is the condition for this one? G dash alpha not equal to
0.
the 0. Then we say at least quadratic. And at least quadratic mean is what? Minimum r equal to 2. Minimum. Not guarantee 1. Maybe 2, maybe 3, maybe 4. And what is the condition? D dash at alpha should equal to. But if teacher say order of convergence is guaranteed quadratic, only quadratic, and quadratic mean guarantee r equal to 2. And what is the condition? G dash alpha equal to 0, but G double dash at a not 0, right? And the same way we can continue for r equal to 3, r equal to 4, whatever we do here. We did some many examples here. Last time you remember we did this example also. We give this example for the double root. And for the double root, when we finish this example, as I say, we have to use the Lupiter rule 2 times here, which is not a good idea because we have to waste over time here. Now I give you generalized example today, inshallah, which is 2 point is a 5 8. And what is this one? And you say x is equal to alpha is the root of multiplicity m of f of x is equal to 0. Then show that the rate of convergence of the Newton method is a linear. Linear mean we have to find g dash must not equal to the 0. So first you have to write the Newton formula. We know Newton formula is what? Xn plus 1 equal to xn minus f of xn taqsim f dash xn. And right side of the xn plus 1, I told you always g xn, g of xn. So this is g of xn in the form of Newton formula. So Newton formula have this one. This is your g. Now you need to what? You take the derivative to show the order of convergence, because to check the order of convergence, we need g and its derivative. And the derivative will give you idea what is the speed of the convergence of the iterative method, or order of the convergence of the iterative methods. So of course, we cannot use the order of the L'Hopital rule here. Here we use the basic definition of f of x. If we have the root, multiple roots with order multiplicity m, what is the definition I give you? Is this one. This is the formula I give you. This formula give you the alpha is a multiple root and its multiplicity is f. So now you have f. When you have f, you can easily find out what? The derivative. You can find by using the product rule of the derivative. And the product rule of the derivative is what? Derivative of the first function which is x minus alpha power m function, which is what? M into x minus alpha m minus 1 into the second function, plus first function into derivative second. What is the derivative of h? Derivative of h is h dash. So you have f. You have f dash. Put the value of f and f dash directly here. And when you put the derivative here, now you have the new shape of g is this one. This is your new shape of the g. And before you take the derivative, you can simplify. Take some common term, cancel, and inshallah, when you cancel term, you can have this is the final shape of the g. Now we are ready to use the derivative. And we use the derivative only one time here to approach to our required solution. What is the derivative of x? The derivative of x is a 1. Now here you have to use the quotient rule of the derivative, f taqsim by g. You already know in math 150. We take this one. Well, you know how to do this one. And when you do, inshallah, you find the derivative of the g is this one. After having the derivative of g, what is your job? Only put x is equal to alpha. When you put x is equal to alpha, what does this become? M of h alpha. Alpha minus alpha, 0. H of alpha. Alpha minus alpha, 0. This is cancelled. Alpha minus alpha, 0. And this is multiplied by whole term in the past. All becomes 0. So what we have in the past only? mh alpha into h alpha. Taqsim divided by mh alpha and alpha minus alpha 0. So mh alpha power 2. This is the things we left here. And that, inshallah, you will get. This is the shape of mh alpha, h alpha, rest all 0. Divided by m of alpha. This is 0. So we can have this shape. You can open this one here. This become mh square alpha. And you open this murabba, the m square h square alpha. H square alpha cancel. 1m cancel. So you have the shape. Final shape is 1 minus 1 over m. What is m? M is a multiplicity. And multiplicity always mean repeating. Repeating mean m should not be equal to 1. M must be greater than 1. And when m is greater than 1, this value will be never equal to 0. So if g dash alpha is not equal to 0, what is that this mean? This mean the order of convergence of the method is linear. Linear means slow, and we already know Newton method converges slow for the case of the multiple, the root we have here. As I told you, I can give you now anything now. This example, we did double root. And we used L'Hopital rule 2 times. Remember last time we did? So what does double root mean? Double root mean your multiple root is repeating 2 times. Right? So it means m equal to 2. So you use this formula, generalize. Don't use the L'Hopital rule here. Just use this for this example. The only thing is what? What is your fx? X minus alpha power 2. And then you can find the derivative. And when you put simplify, and inshallah you will get what? 1 minus 1 over 2. And 1 minus 1 over 2 is half, which is not equal to 0. Of course, exactly the same answer we have here now. But we have the answer here is a half. So no need to L'Hopital rule here. In exam, as I told you, once I give that alpha is the multiple root of multiplicity 7. So 7 mean m is equal to 7. So only things you replace here is what? Is a 7. Place all m by 7 and simplify this one. What is the jawab? 1 minus 1 over 7. And this is not equal to the 0 we have here. You got my point, please? So this example, 2.58. It is the generalized example to check the order of convergence of the Newton method for any multiplicity of the root, multiple root. Any question up to this example, please? Is it okay?
Yes, clear.
Right. Now, let's say I change this example now. I change this example. I say x is equal to alpha is a root of multiplicity m of f of x is equal to 0. Then show that or find the rate of convergence of modified Newton method. So what is modified Newton method? What we have to change here? If we, this is a Newton shape. What is the modified Newton shape we have here?
We multiply the second term by m.
Yes, only we have to multiply by m. So when you multiply by m, then you behave like same thing. The only thing here, multiply by m, multiply by m, and multiply by m, and multiply by m. M taksim by m is equal to what? 1, and 1 minus 1 equal to what? 0. And 0 mean the quadratic, at least quadratic. And we know that the modified Newton method is converge at least quadratically. Minimum is 2. Fast, because modify is the best formula for the multiple root. This is a problem I give. This I'm talking about. I say if x is equal to alpha is a root of multiplicity m of the nonlinear. Show that the rate of convergence of modified Newton method is at least quadratic. At least quadratic means g dash alpha must equal to 0. So first thing you always have to do, as I told you, when you're dealing with the order of convergence, you need always what? You need always g. And what is the modified new formula in the form of g? It is this one, because what is your modified formula, please? I told you it is x minus n plus 1 equal to what? xn minus m into
Fx
f dash
over
x minus n taksim divided by f dash.
the first one is f, not f dash.
First one is f, yes. This is the formula. And I told you, what is this one equal to always?
G of x.
G of, because anything on the right hand side of xn plus 1, we can call it g of the xn. So what you have g for that case is x minus f m f taksim by. This is the things I mentioned here. Now you have the value, this one, you know how to find f. This is the definition here. And then you put the value here and only add it in the previous example, and difference between previous and this one, only we have to add one term m more here. So we have an m here. When you take the derivative, when you simplify after putting x is equal to alpha, inshallah you will get this one. This is m square h square. This is also m square h square, which is cancel each other. You got 1 minus 1 0. Therefore the method of the convergence of the modified method for the multiple root is at least quadratically. We have at least quadratically. So example number 2.58 and 2.59 are generalized example for the case of multiple root of the Newton and the modified Newton cases you can have here. Now this is the example I gave in the final exam one time. You say if x is equal to alpha is a root of multiplicity 5 of f of x is equal to 0, then show that the rate of convergence of the modified Newton method is at least quadratic. Newton formula is this one. We know here, what is m? is a
Five.
5. So only things you have to do. Now this is your f with m5. Do the same thing, same procedure you have after simplify, putting the value of f and f dash in the g. Then you can take the derivative and you have what? Same thing, 5 square h and 5 square h square. So cancel each other. So we can have here is. So in exam, teacher can give you generalized case in place of m. He can give you anything, 7, 20, 2 million, 4 million. So no problem. You can take only one time derivative. If he give you 200, multiplicity 200, so what that mean? Is x minus alpha power 200 into h, and then you can take the derivative of 200 easily here. So this is a best example for the case of multiple root convergence of the multiple root iterative method for the multiple root Newton and the modified Newton, and we check modify Newton method for multiple root at least quadratic, but Newton is a linear. And this is true because Newton is slow for the multiple root. It is only fast for the simple root, which I give you the example last time here that show that the Newton method rate of convergence is at least quadratic for the simple root. And simple root, what we show? G dash alpha equal to 0. This is only G dash alpha equal to 0 Newton case when you are dealing with the simple root of a nonlinear equation. So we finish the third part of the chapter. The first part of the chapter was what? We discussed linear equation, a nonlinear equation, and we find only approximation of its simple root by using bisection method, Newton method, fixed point method, and secant method. Among them, best one is the Newton. Then second part of the chapter, we discuss what? We discuss the multiple root and its multiplicity. And multiplicity mean how many times your multiple root is repeating. And for that, we use one numerical method, which is modified Newton method, and which is the best method for the multiple root. And modified Newton method, I give you two shape, one with the m and one without m. One with the m you can use only if alpha is given. If alpha is not given, so you cannot use the first shape, you have to use the second shape without m. And then we did the third part of the chapter, and the third part of the chapter we find out the rate of convergence of the iterative methods. Iterative method we already consider converge, only we need to check its order of convergence or the speed of convergence, slow or fast. Slow mean G dash alpha should not be equal to 0, which in other way we call linearly, and fast mean quadratic or at least quadratic for that case. So, any question you have for the iterative case? But one thing, remember that one here, please don't be confused with order of multiplicity and order of the convergence. For order of multiplicity, we need f, and order of convergence, we need g. That's the difference. We find multiplicity by taking the derivative of f unless it's not equal to 0. That order which is not 0 is your m. And the same way we take the derivative of g unless the derivative of g is not equal to order of the derivative of g which is not equal to 0 at alpha, that is the value of r. A student always confused in the exam with the order of multiplicity or that. Sometime in exam, teachers say use quadratic convergent method. So when he say quadratic convergent method, it simply mean the best method. So we have a two best method in up to now. The first one is a Newton for the simple root and modified Newton method for the multiple root. So don't confuse with this one, because when teachers say use quadratic convergent method and then a student find out the G. No, we can quadratic convergence method mean the best method. Either Newton or multiply. You have to check your alpha is simple root or the multiple root. Simple root, go for the best formula, quadratic convergent method, faster method, which is the Newton one. And if it is multiple root, go for the modified formula, which order of convergence is first. Any question, please? Any student? No, it's mean everything is okay. Let's move to the last topic of the chapter number 2. Then we are ready for our the first short test concerning 10 marks, which will become very soon in the 3rd week of February, in the 23rd, which I mentioned you, 23rd of February, inshallah, between 8 and 9 in the evening time. I will mention you, inshallah. We will not take 1 hour exam. Maybe we will take 40 minutes or 45 minutes, depending on how many questions I will give you. Let's take the last topic of the chapter, which is called system of nonlinear equation. What is the meaning of up to now? Remember what we discussed up to now. Up to now, we are given only one nonlinear equation, and we denoted it like this one here. F of x is equal to 0, function of one variable. And we find the approximation of the root of x. What we do, we find approximation. We find approximation of x is equal to the alpha. This is your job, right? Maybe alpha is a simple root or a multiple root here. Now, what we have only one equation. And what we have to do, system of nonlinear equation. What is the meaning of the system? System mean you deal with more than one nonlinear equation. More than one nonlinear equation. Maybe 2, maybe 3, maybe 4, maybe 5 at a time. So it's mean we have to discuss system, but we discuss only in 254 system of 2 nonlinear equation. And if you have one nonlinear equation, how many function you have? 1. How many variable you have? 1. Now what we have here now, in the case of 2 nonlinear equation, we have a 2 function and 2 variable. 2 function mean 2 nonlinear equation. And the idea is exactly the same. How to find 2 function? Take all the term one side, make one side equal to 0, and non-zero side is your function here. So now what we have to do, we are given a system of 2 nonlinear equation with 2 variable, which is this one. First equation give you this function, second equation give you this function here. So before we have to find approximation of x, now we will find approximation of x and the y we have here now. We are given 2 equation, so we have this one. We have to find, this is an exact equation because A and B, A mean alpha, B mean beta. These are the exact root. We have to find approximation of alpha and the beta in this case. Now we have very simple one. That's the things we have to do now. We have to find what? Approximate value of alpha and beta such that this condition is 0. And alpha and beta exact solution always give you 0. But we are not finding the function 0. We are finding the value of the function should be close to 0 because we are dealing with the approximation of alpha and the beta here. The both alpha and beta are root of a nonlinear system, and the root only we discuss is a simple root. Is it the simple root? You remember that one? For simple root of one nonlinear equation, we discuss 4 methods. All 4 methods we can use for the system also. But we will use only one method, which is the best for the simple. And we know which one is the best for the simple.
And Newton.
The Newton. So we have to use only the Newton formula for. That's the things we have to do. The Newton formula for solving nonlinear system of 2 equations. And that's, I developed the formula, no need to for this. This is the formula we have here now. This is before what we have, please. This is a Newton formula for one case. Xn plus 1 equal to Xn minus F taksim F dash. Now we have a 2 X and Y. So I put in the matrix form here now. This is your, in place of Xn plus 1, we have Xn plus 1 and Yn plus 1. In the matrix form, I put here 2 by 1 we have. And here we have initial approximation and Xn. Here we have Xn and the Yn.
Oh, yeah.
Minus, yes, a minus. Then we have a, in the first, we have a 2 function. Here we have a 1, but here we have 2 function, F1 and
F2.
F2. Then taksim by derivative. Here we have a simple derivative. Why we have a simple derivative? Because we are taking derivative respect to only one variable. Now we have, in our this case, we have a function of 2 variables. And the function of 2 variables generally we call partial derivative, which we do this one here. It's mean, how can I denote F for our case now here? I call F dash is just like J. J for the Jacobian matrix. I give the name because this is the matrix we have, and I give the name of that matrix, special matrix we call Jacobian matrix. And what is this one? Formula, derivative of the function with respect to function 1 with respect to x and with respect to y in the first row, and the second row you have the derivative of the function with respect to x and y with respect to second function in the second row. Then you take the in the denominator, then I took on the up. Then when took up, it become inverse. That means you have to need to find Jacobi matrix for the derivative, partial derivative, and then take the inverse of that one. You can easily find inverse of 2 by 2 matrix. One of the simplest case to find inverse of any matrix. The matrix 2 by 2 here. Ask God. If you have a matrix 3 by 3, 4 by 4, your inverse become difficult. But 2 by 2 is a very simple one we have here. Therefore, we use system of 2 nonlinear equation here. You multiply this together, make subtraction from initial approximation, and alhamdulillah, you will get the new approximation of the alpha and the beta we have. This is the things we have here now, which we call the Newton method for the case of nonlinear system of 2 equations. Let's redo this example. You can understand here now. This is I show by graphical. You have a 2 equation. One is this equation, other is this, and we look for the point of intersection here. Let's take this first example we have. He says solve the following system of 2 nonlinear equation using the Newton method with the accuracy, this one here. Of course, I told you in exam, I will generally not give you the accuracy way the question. I will give you with first approximation, second, but 99.9 or maybe the 100% guarantee. When we use system approximation, we use the first approximation only. So he say, given question from examination point of view will be look like this one. Find the first approximation of the nonlinear system with the help of Newton method. And of course, as I told you, Newton method need initial approximation. Now we need 2 initial approximation, one for x and one for y, always given by the teacher. So you have this one. So you have a two nonlinear equation. It means you have to do two jobs, which usually we do in the case of the one equation. We find first function, then we take its derivative. Now we have a two function because we have a two equation, and we have to find the partial derivative. What is your first function? Your first function will be 4x cubed plus y minus 6, because we have to make one side equal to 0. What is your second function? X square y minus 1. This is your second. Now you take the derivative with respect to x and y. When you take the derivative with respect to x, we consider the other variable must be constant. So what is the derivative of 4x cubed? It's a 12x square. What is the derivative of y with respect to x? Is a 0. This is 0. So we have this one. Then we find the derivative of first function with respect to y. This is 0. This is 1. And this is 0. So we have a 1. Same way we behave with the second function, which is like this one. This is your second function. Derivative with respect to x is what? 2x. And to y we have this. And derivative with respect to y is what? Is 1. And this is x squared. So we have this. Now you have the value of the function. You have the derivative, which give you the Jacobian matrix. We need to find the value of the function and their derivative at the given initial approximation 1 and 0.5. When you find this one, your function value at this initial approximation is minus 1.5 and minus 0.5, and the function value derivative is 12, 1, 1, and 1, and then you can have, what is your j? J is this formula. What is partial f1 by partial x at the given is a 12, y is 1, f2. Here is a mistake here, please. This is partial f2, not 1, right? Because we are dealing, here is okay. This should be 2 here. I will correct it, inshallah. So this is 1, and this is 1. So we have this one. Now we can easily find out the inverse. You know how to find the inverse of 2 by 2. 1 taqsim determinant. What is the determinant of this one? 12 minus 1 is 11. And interchanging the position, interchanging the sign, you have this. This is your J inverse. Now you got everything ready for the formula. Put n is equal to 1, 0, sorry, in the formula you have x1, y1, which is equal to x naught given by the teacher, y naught given by the teacher, minus J inverse. You just calculate it here. And f1 and f2, you just calculated by yourself, and that's the thing. Then use calculators, simplify this expression, inshallah, you will get. This is the first approximation of the root of a system with the help of Newton method. But I here in the table I show 3 iteration. Why? Because in the question I mentioned with the accuracy 10 minus 5. Of course, in the exam we cannot give you the 3 approximation. In the exam must be only the first approximation. Now in this question can become in the exam 2 ways. The first way, which I solve here, find the first approximation. This is the jawab. Maybe sometime in exam teacher not interested in first approximation. Teacher interested only find the J and the J inverse, right? So that means you find the derivative of the function and then find the matrix J and take its inverse. That's the jawab. No need to continue like this one, because he never asks you to find the first approximation. He say for this system, like this here, he say, here I solve the following system with the help of Newton method, right, with this. But if I, maybe in exam I say, find the Jacobian matrix and its inverse for this system, this initial approximation with the help of Newton method. So that's the things you have to do this one here. Agree? Any question? Today, no, because everyone is okay, good. Well, alhamdulillah, if everyone is good. Let's take one more example. Same thing. I say find the second approximation of the point of intersection of the equation, this and this. And your equation are, of course, what? Your equation are nonlinear. So this is the same thing. You are given the nonlinear equation x cubed plus y equal to 1 minus x plus y equal to minus 1 and initial approximation given 0.5 and 0.5. So this, you need F1, you need, this is F2, please. This is F2, not F1. This is F2. I will correct inshallah. Then you can find the derivative. This is okay. Find the derivative, partial derivative of F1 and F2. You can have this one. And then find the value of the function, first and 2 at the initial approximation given by the teacher, which is this. And then find the derivative at the given initial approximation. We have this one. Again here, please, 1, it should be 2 here. So 0.75 minus 1, 1 and 0.75. You take the inverse. This is the inverse here. You have value of the function is this one, F1 and F2. So you multiply this together. And inshallah, you got the first approximation. Now, in this question, I say find the second approximation. It means you have to repeat all this process again with the new approximation, because we did this procedure with this approximation. X naught is a 0.5 and y naught is equal to 0.5. You have to calculate your function value again, their derivative value again, and their j and j inverse with the new approximation. X1 is 1.08, which we just got now. Y1 is 0.04. And inshallah, you will get this shape of the Newton formula, which give you this one, the exact, the second approximation of the point of intersection. And we know what is the point of intersection, the exact jawab. We are not finding the exact. Exact is 1, 0. So 1 is not bad, very good, about 0.95. And 0, we have 0.2. So it's not bad here because we only did 2 approximations. That's the things we have here for the case of the second approximation by using the formula 2 times. That's last example of this chapter. We are given 2 nonlinear equations, x cubed plus 3y equal to a, and x squared plus 2y equal to minus b. Then I say, because we don't know value of a and b, my question is use Newton method for the system of 2 nonlinear equations, which initial approximation is this one. And the first also given by the teacher. So no need to find the first one. He said find the value of a and b. So you have to do same way. We have, what is your first function? Take all the term one side. And you can take the derivative, because derivative of x with respect to x is 3x squared. Derivative of y is 6y, because this is constant, 0. Second function, you have 2x and 2. Then you find the value of the function at initial approach. This is again 2, please. I copy and paste. Therefore, we have the same mistake again. Now here mistake here, please. Because you need to find f of 1 and minus 1. What is your f of 1 and minus 1? 1 plus 3 minus 1 square means 3, 4, 4 minus a. Here I write in the formula is correctly, but there I make mistake here, right here. This is your f1 is what? Your f1 is not minus 17. It is 4 minus a. And what is your f2? Is a minus 1 plus the b we have here. Now then you put the value here. You have the j is this one. Take the derivative of, inverse of j. You have this one. Use the formula. You are given x1 and y1 by the teacher already, which is this. Initial approximation is this. This you calculate by yourself. Multiply together, then equate. And inshallah, when you equate, you have this 2 system of 2 equation, a and b. and solve for A and B, you can get, inshallah, A equal to 21 and B equal to 2. This is the required solution of the system of nonlinear equation with the help of the Newton method. Exactly the same way we did here. What is the difference here? The difference here, in all two previous example, we are given the right hand side. We need to find x1 and y1. But in this example, we are not given the right hand side. We have to find out. And what we are given x0, y0, x1 and y1. So only we use the formula. This is the things we use here. And when you simplify, inshallah, we will get the jawab. That is the fourth part of the chapter we have here, which we call the system of two nonlinear equation. And we find the approximation of alpha and beta with the help of Newton method only. We finish the chapter. I never say I finished the chapter. I say we finished. That means you also finished the chapter. Any question you have in any topic, you can let me know. I can repeat that topic again. Or if you have any question concerning with today's lecture, please ask me.
I have a question, Doctor.
Yes.
How we get the J inverse?
J inverse is a very simple formula. You remember the J inverse. How can you find here?
1 over the number we.
Yeah, this is the thing. You have A matrix. Let's say call in A. First row is A and B. I'm right? What is the second row of the matrix is C and
D.
This is your 2 by 2 matrix. How can you find the inverse of 2 by 2 matrix, right? The formula is simple is 1 taqsim the determinant of A, right? And determinant of A is what?
AD.
AD minus
BC.
BC, right? And what is the matrix shape now become? D multiply the matrix D n minus B. And what is the second row of the matrix? It is minus C n
A.
This is the formula we have here in the form of matrix we have here. I think I should mention this one here. I will mention inshallah 2 by 2 matrix in this book somewhere, how to find inverse of 2 by 2. But this is a very simple one. You have this idea in math 1007, I think, 244, something like this. Is okay with you now?
Yes, it's clear, Doctor.
Good. Any other question, please? So please, we finish our chapter number 2. It's a big chapter we have here now. As I told you, we will do inshallah chapter 2, chapter 3, 4, 5, and 6. Only 2 big chapters we have in this syllabus is 2 and 3. If we finish 2 and 3, alhamdulillah, we finish maybe the 70% of the syllabus. Because chapter number 6, we can finish in 1 lecture. It's a very short chapter.
Doctor,
Yes.
what topics are left in chapter 2?
We finish everything.
Did we just finish everything in the chapter 2?
Yes, we finish everything.
Bisection, secant, and the Newton modified, and all of these things?
Yes, we finished.
Okay, thank you.
We start from the first part, which, as I say, we did approximation of the simple root, which we use 4 methods: bisection method, fixed point method, Newton method, and secant method. Then we finish this. Then we move to the multiple root. And for multiple root, we use modify Newton method. We finish. Then we finish order of convergence of the iterative method. And then we finish the last topic, the system of 2 nonlinear equation approximation with the help of the Newton methods. That's the syllabus of chapter number 2 for the case of 254. Here I mentioned that if you have n by n linear equations, then of course, as you increase this equation in the system, your J become difficult and difficult, because to find the inverse of J is not an easy job here. Therefore, we use only system 2 by the 2. That's the exercise I gave. You can use for practice like that one here. Is okay? So hopefully, as I told you, I already mentioned you, or you can go to my web page. You can find all the information on my web, which is, I told you, the fac.ksu.edu.sa/Rizwan.bu. You find all the information, and I already put the syllabus that you have your first short test or quiz. I think is 6 week on 23rd of the February, and it is on the evening time between 8 and 9. It's not 1 hour exam, maybe 40 minutes or 45 minutes, depend. I think I'm trying that I will give you 8 multiple choice problem, and each multiple choice problem will be 1.25. So 1.25 multiplied by 10 is become multiplied by 8 become 10. So 10 is your first quiz, 10 is your second quiz, 30 is your what you call the midterm only one, and 10 is the marine marks. Maybe 45 minutes I will give you for the things. I will put on LMS and I give you the password, then you can do inshallah. Right? Any question? Now what you have to do, please, you remember, I think you got, last night I sent the link for my lecture recording, right? I will send you this one also. So you have all the lecture with you. So please read that one, listen that one. If you have any confusion, you can discuss with me by WhatsApp or by email. We can discuss. If you have a big problem, then we can make a meeting online again anytime in the evening time, and we can discuss inshallah. Don't worry. Okay.
Doctor,
Yes.
you send the new numbers for the serial numbers.
Yeah, this is the final number now. You have to use from today that number.
I'm not sure if I am attended.
What attended?
I am not sure if I said my number or I said someone else because you changed it.
No, but you know the number now.
I think it's a number 5.
Your number 5.
مشعل.
What is your name?
مشعل Abdullah.
Yes, this is number 5. Al Sheikh.
Yes.
Yeah, your number 1, 2, 3, 4, 5. Yes.
Yeah, I want to double check. Okay.
Yeah. So now you talk is a number 1. So please, we will call according to this sheet. Now I think there will be no change now. Okay, so we will use this one.
Okay.
Right.
Yes, doctor. I have the same problem. I was before number